Okay, hi, welcome back guys. Let's continue with our derivation, and now we want to clean up the denominator. Okay, so first thing I want you to know is that these two look like they are a common denominator. So let's do this. Common factor. So let's factorize our I and ki. That's part one of cleaning up our denominator. So let's have I over ki on the outside, and we have this bracket, a bracket km prime plus s. And what do you know? It just so happens that km prime and s, km prime and s. So this you can factorize a 1 out, which we are not going to do here. So in the other way you can look at it is we factorize km prime plus s out. So we have this Vmax over s, and then we'll have this out, s plus km prime, bracket 1 plus I over ki, and close bracket right there. And what do you notice? This part looks very similar to our standard Michaelis-Menten equation. And this, well, you can have it combined with this. And so we can see effectively what this non-competitive inhibition actually does to our kinetics. So you have S, Km prime. So effectively, everything else here can be considered constant under the rapid equilibrium assumption. And well, you can see that our non-competitive enzyme kinetics actually slow down, or rather decrease Vmax. It decreases the maximum rate of the formation of the desired product. So this, we'll just call it Vmax apparent into S over S plus Km prime. So this is our standard. And of course, you plot the graph again, you can get the usual Vmax apparent and Km prime. So well, of course, we assume this is more than 1. And Vmax over this will give you this apparent Vmax, this term called Vmax apparent, and it will be such that Vmax apparent is less than Vmax. So it decreased the maximum rate, and that's pretty much what non-competitive enzyme inhibition does. Okay, this is a relatively short segment, of course. But yes, we have finished deriving our enzyme kinetics for non-competitive inhibition. I hope this helps you know a little more about what this non-competitive inhibition does. So thanks for watching, guys. See you.